Yeah, my name is Alok. I used to be an MC member at TZ last year, so I was responsible for some of the water management stuff. And Shekhar is here, who was an MC member and a president before that, and was instrumental in some of these things. So we can, try to take you through that. So we claim that TZ is a water neutral campus, and it is not to really, boast about being water neutral, but to say what our journey was to getting there. So I just wanted to take you through the steps that we took to what we claim is water neutrality. Uh, First of all, what do we mean by water neutral? So the idea is that the amount of water we draw out of the ground is at least amount of water we recharge into the ground. So at the end of the year, we can claim that what rainfall fell onto our campus is approximately equal to what we drew out of our ground. So that's what we mean by water neutral. So the question is it really possible? And with all the water woes we are hearing and with the rainfall that we get in Bangalore, is it possible to really do that? So let's first see how we live in TZ. We get RO water in all our taps. So that means all our taps, bathroom taps, kitchen taps, everywhere. We get RO water in our showers. We even get RO water in our toilets. So that consumes some water. So the question is, in spite of all this rampant wastage, can you still be water neutral, right? And the answer is a big yes, and we'll take you through the journey, how we reached there. So the first thing is reduce. How do you reduce? It's all common sense. It's not like rocket science. Even rocket science is not rocket science, and this is just water, right? So use low flow showers, use aerators on all the taps, use efficient flushes. So this was a big problem. We used to have flushes which used to leak water. They would stay on in the on state and just continue draining water. So we pretty much replaced all the flushes in the whole campus, one by one. So it wasn't done at an MC level, but we did enough advocacy to make sure that all the flushes were replaced. Plug leakages, again very big. So the most important thing in plugging leakages is first you have to measure your usage. You have to make sure that you know when your usage is climbing from what it used to be so that you can find leakages. You need to know that I started with this much water at this point and this much is reaching me. So you need to measure at various places to identify your points of leakages. So we had various leakages. So sump had a leakage. From the sump to the apartment pipe had a big leakage. So we plugged leakages one by one. So that was a big source of saving. And evangelize. So each GBM, each general body meeting we have, we would show what our water usage is and how we are doing per apartment. So you need a core set of people who are very passionate about it and who are willing to spend some time and shout from the rooftops. Each GBM will harp again and again on the same message. So that's very important. And you don't have to give up. You just have to keep doing it. So what is the result of all this? The result is that our water consumption is approximately 150 liters per person per day. So which, as the chairman was saying, even the government mandates around 125 to 130 liters of consumption per day. So we are fairly in the ballpark, given that we have a fairly large campus with low density of occupancy and fairly large apartments. I think this is a fairly decent usage level. So that would mean approximately 500 liters of water per apartment per day, including the villas. So we have around 15 villas and 76 apartments over a 5-acre campus. Then second is Replenish. So we have a very extensive rainwater harvesting system. We have around 5 deep bore wells and 34 shallow bore wells in the campus. So all the rainwater is harvested. So the result is that in our campus we have 4 bore wells, out of which we use only 2. 3 of the bore wells are at the depth of 150 to 200 feet. So one bore well is actually at 80 feet. around our area, most bore wells are around 700 to 800 feet. So in our campus, we are able to get water at around 150 feet. Reuse. So as I said, we have the RO reject, which is 30% of our water comes out of RO as reject. So we use all of that water for gardening. So since we have reasonable amount of gardens, so instead of using our STP water for gardening, the RO reject water is used for gardening. The STP water is used for car washes. The result is that 30% of water, RO reject water that would have gone waste, is now preserved. So we do not use fresh water for our gardening purposes. Recycle. So this is the kind of innovative thing and what has put TZ kind of made notorious. So we use, let me take you through. We have clean water, which obviously becomes sewage water everywhere. The sewage water goes through a sewage treatment plant and filters, and should ideally come out as fairly clean sewage treated water. So comes out of the STP plant, and most of us either reuse it in gardens or flushes or throw it out of the campus. But what we do is we treat it through another level of filters, and we already had a RO system, which I showed in the beginning that we were getting RO water in all our taps anyway. So we take our STP water back into the RO system, and we close the loop, and the water comes back into our taps. So thank you. Yeah. So there is no differentiation.
Just to add to that, I believe in Singapore they are doing this already.
Yes.
10% of the water, fresh water they get from Malaysia. The rest, 90% is actually done like this.
In London as well.
Oh, is it so?
Oh, Japan also.
Okay.
Yeah, in Whitefield also.
So the STP water is back into the kitchen tap. So
How do you test the level, the STP water?
okay, so Shekhar will probably go a little bit more into that, but the short answer is there are 2 points to the answer. First answer is that the borewell water we get, or not the borewell water, the tanker water we were getting earlier was dirtier than the STP water. So to answer your question, first look at your tanker water. If you are willing to take that, then you should be willing to take a properly treated STP water, right? Second answer.
No, just 1 second. Let's keep the question. We're going to have.
Say. Yeah, no, I'll answer.
Sir,
So,
sir,
all the technical details.
Yeah.
yeah.
Please hold on to your questions. We'll have a panel, after that, after we hear from all of them. That'll be easier.
So Shekhar will go a little bit more into, he has the technical diagrams to satisfy your curiosity. So ask all the hard questions to him. So the result is that, 35% of water which you would have drawn out of borewells is now taken back from the STP. Okay, so we hear that STP is expensive. A lot of apartment owners or associations and builders say STP is expensive. But what we have found is STP is fairly sound economics. We get 60,000 liters of water from STP. So out of which 40,000 we are reusing into our system. So that pretty much comes out to around 4,000 rupees of savings per day, which is around 1.2 lakhs per month. And the cost of running the STP, when I say cost of running the STP, I'm including everything: energy cost, manpower cost, chemical cost, all of that is around 1 lakh per month. And the other thing to keep in mind is that it's a statutory requirement. You don't have a choice. You have to run a well-functioning STP. So if you are able to run a well-functioning STP, there is no reason not to, actually reuse it. So what is the end result? Now I come to our water neutrality. So we draw approximately on an average 55,000 liters of water per day from our bore wells. We run 2 bore wells per day from around 8 in the morning to around 8 in the evening. We have 4 bore wells, but we need to run only 2 of them. Say it again?
No.
Or can see.
Water usage from other
Yeah.
sources must be zero.
So the average rainfall in Bangalore for a 5-acre campus is around 55,000 liters per day, based on 100 centimeters per year. We don't get any water tankers. We don't get anything from BWSSB. We don't want anything from BWSSB. We have zero water which goes out to drains. No water, not a single drop of water, whether it's raining or not raining, goes out of TZ campus. So our water deficit at the end of the day is zero. So, thank you.
What is the cost of running that RO plant?
Uh, okay.
So please, this is a very rich session, so what we will do is, let them individually present. All of them are going to be in the panel. It so happens we also have the builder representation from the apartment complex. So we can have a rich Q&A session with all of them in the panel. I think that will be more useful. Yeah.